Good evening and happy Monday. Fair bit of warning. They are calling for thunderstorms in my area, so if I just cut off, it's probably because I lost power. We are starting trigonometry today. Before we actually start looking at the trigonometric functions, we're going to look at angles. All right. Typically speaking, when we think of an angle, it is generally being measured relative to the positive x-axis. Okay, seriously. All right, so that would be our angle theta. That's the line segment OP, also called a ray. Now, if you imagine this point, so we have a point there, right? And we look at this ray. Call that point P prime. We're going to say that this ray has a length R, okay? We keep the starting point right here the same at O, right? We're also keeping R as a fixed length. Well, what would happen then if we start to rotate P? We get a circle, right? Right. So theta is also thought of as essentially the amount of rotation on a circle. Right, so it's essentially a measure between two radii. This little bit here is an arc. Right, so that would be an arc. And then this slice, you can think of as like a slice, a pizza slice. So that entire slice is a sector, right? Sector of the circle. There are two units of measurement used for an angle. What's one of them? Degree is one. Radian is the other. SI units are the radians. Right? In fact, unless specified otherwise, the unit will always be radian. The radian is actually a unitless measure. Right? So what does that mean? Well, measuring distance, right? We'd say we're 8 kilometers away. Right? The SI for length is, I think, the meter, but we commonly use kilometer. Right? For time, we're like 8 minutes away, right? Minutes would be the unit of measurement. Force, the Newton, is a unit of measurement. When we talk about angles, this rotated 3, right? We don't typically say 3 radians, right? If we say that, it's because the radian, the rad, is a placeholder. It's not an actual unit, right? So we'd say we have an angle of 3. If we're dealing with degrees, obviously degrees is a unit, so we'd say we have an angle of 32 degrees. We do 1 full revolution of a circle. What's the angle measurement? All right, so 360 degrees. What about radians? has to be the same. Two pi rad is equal to 360 degrees. That means pi is 180 degrees. That's our conversion factor. Now, that's the equation that we will use whenever we want to convert between radians and degrees and vice versa. And going back to the coordinate plane, since we know if we take a point, hold the length fixed and the starting point fixed, the initial point, and we begin to rotate it, it's going to cover one circle. All right, that means the positive x-axis is going to represent 0 radians. The positive y-axis represents pi over 2. Negative x-axis represents pi. Negative y is 3 pi over 2. And then when we come back to the positive x, we're back at 2 pi. The degree can be broken down even further. It is not very common. Right, we have the arc minute. One degree is equal to 60 arc minutes. Right, in other words, an arc minute is 1/60th of a degree. Then we also have the arc second. One arc minute is equal to 60 arc seconds. Right. So an arc second is 1/60th of an arc minute, or 1/3600th of a degree. We don't call it the arc hour, but that would be the degree. So you may see something like it might say something like that. Find the angle in DMS format. Right. All DMS format means is degree, arc minute, arc second. Right. And we're going to see some of those formats. Oops. That was a mistake on my part. Let's fix that. That's better. So problems 1 through 9, we're going to be given an angle in degree, and we're going to be asked to convert it to radians. Right. So anyone who's taken any kind of science class, right, physics, chemistry, should be familiar with unit analysis. Right? How to convert between different measures. Well, remember, pi is equal to 180 degrees. Right? That would mean that 1 degree is pi over 180. Right, so pi over 180 degrees is what we're multiplying by. Degree over degree, the units cancel out. We're left with 30 pi over 180. Which is pi over 6. 135 degrees. Still multiplying by pi over 180 degrees. We get 135 pi over 180. Just 3 pi over 4. $25 degrees and 30 arc minutes. What you could do is try and find the conversion from arc minutes to radians. Right? Or recognize that 30 arc minutes is 30 over 60 of a degree. Well, that's half a degree. Right? That means 25 degrees, 30 arc minutes is 25 and a half degrees. Which is 51 halves. We can now multiply by pi over 180 degrees. Right? $51 over 360. Both are divisible by 3. $17 pi over 120. $42 degrees, 24 arc minutes, and 35 arc seconds. Right? So 24 arc minutes would be 24/60ths of a degree. 35 arc seconds. (35 over 36/100th of a degree). Oh boy. This will simplify. (6,107 over 144). All right, so that's the degree. Should probably just be safe and double check that. Yes. Now we multiply that by pi over 180 degrees. (6107). Sadly, has nothing in common with 180. Right. 144 times 180. It's 25,920. Right. That means in radians, our angle was 6,107 pi over 25,920. That cannot be reduced. The TI Inspire can do it. And so you calculate, if you just type in the fraction, it will automatically reduce it for you. You do not need to memorize the unit circle. We're not even there yet. However, you will not be given a sheet with the unit circle, so you'd have to write it down in your notes. $165.7. So go ahead and multiply that by pi over 180. Right? There are two ways we can go ahead and represent this problem. The first would be to keep it in terms of pi. That would leave us with 165.7 over 180. Find out what this reduces to. Um, 0.921. We could also just approximate that product. Right? We don't have to write it in terms of pi. Let's do it this way, divided by 180. What's the value for pi? Now, So you're saying it's exactly 3.14? So exactly 3.1415926,536. Right. We typically take pi as 3.14. However, that is a very weak approximation. Pi does not have an exact value that we can represent in the decimal system. It is transcendental. It is an irrational number. When you're trying to approximate something with pi, you'd be better off not using 3.14 and just using the pi command. Right. On the TI Inspire, a couple ways you can do that. First, right down here, you click what's red. It's going to bring you up a list of symbols. Then you just hit enter because it's already highlighted on pi. Then hit enter again, and there would be the approximation. Let's say 2.89. Another way you could do it is just write out pi, pi, and then hit enter. And you see it's the exact same thing. Unless the problem specified one way or the other, I'd accept either answer. Negative 3.85 degrees. This is our first time looking at a negative angle. I want to try and keep it on screen. Let's say there's our ray. A positive angle would be measured that way. in the positive direction from the positive x-axis. When dealing with rotation, the positive direction is counterclockwise. If you're measuring the angle moving clockwise from the positive x-axis, the result is a negative angle. All right. So the plus or minus is simply dictating the direction of rotation that you're using to measure the angle. Negative 3.85 degrees it's 3.85 degrees clockwise, clockwise measurement from the positive x-axis. Right, again. Going to measure that, multiply this by pi over 180 degrees. So we again have two ways we can represent it. We can either represent it in terms of pi or also get rid of pi. And notice I'm not putting a negative because I know that I'm going to multiply by negative anyway. Point 0.021, let's say 4. That'd be if it's in terms of pi. All right, or negative 0.0672. What's going on? Thank you. Yeah. Yeah. Okay, look at negative 205 degrees. Multiply by pi over 180 degrees. Be negative 205 over 180. At the very least, they're both divisible by 5. All right, so we have a 5 in common. All right, negative 41 pi over 36. Negative 18 degrees and 30 arc seconds. All right, that would be negative quantity, 18 degrees plus 36 hundredths of a degree. Thirty over 3600 would be 1 over 120. Right. Then what is 18 times 120? $2160. Then we get negative 2160 over 120 degrees. Or 2161, I think. I think I said 2160, right? 2161 over 120 degrees. Multiplied by pi over 180 degrees. $21.61 and 180 do not have a common factor. $120 times 180. $21,600. There's the radian measure. Right. Negative 0.21 degrees. Multiply that by pi over 180. So as a general rule of thumb here, you're not going to put it in fraction form. Negative 0.0012, let's say. Negative 0.0012 pi. Right? Or if you want to get rid of the pi, negative 0.0037. Right? As a rule, whenever you're given a decimal, right, as we were in 9, 6, and 5, then the answer that you're going to be giving is also a decimal, an approximation. If you're not given a decimal, then you want to give it an exact form. Right. Again, anyone who's taken any kind of basic science class is familiar with this and is familiar with the rounding rules. Right. So how did I, for instance, decide to stop here? Okay. So there's actually two separate rules to use. Oh, there's actually three. Right. There's the rounding itself, right, which everyone should be familiar with. Right, you look at the digit after where you stop. 5 or, well, actually, this is where there is debate. There's several ways of doing it. The most common is 5 or above rounds that number up. Below 5 rounds it keeps it the same. Right, so that's how I got the 0.012 2, because after the 1 was a 6, that rounds that 1 up to a 2. When dealing with operations, there's a rule for when you're doing addition and a rule for multiplication. Addition, you keep the fewest number of decimal places. Multiplication, you keep the fewest number of significant figures or significant digits. Couple rules.
And fix things. And fix what I broke, and you fix also and make things better.
You both are gonna fix things and make things better.
Wow.
Do you want to be in a relationship with her?
Sure.
Look.
Okay, let's just pretend that never happened. Leading zeros are not significant. Right, that means this leading zero is not a significant figure. Just the 2 and the 1 are. So that'd be 2 sig figs. trailing zeros are not significant. Unless they are followed by a decimal point. That number, 2 significant figures. The 1 and the 8. All of these trailing zeros are not significant. Now it's 12 significant figures. Right? Because now the trailing zeros are followed by a decimal point. So that makes each one of these zeros significant. However, those zeros would not be significant. So if we look at this 180 right here, how many significant digits is it? Well, technically you're correct, it's 2. However, I got that 180 from a conversion factor. So it's actually implied to have a decimal point following it, even though I don't write it. Right? I know that that is exactly 180. I know up to the unit. So it's actually 3 sig figs. We did multiplication with 2 sig figs and 3 sig figs. The fewest number of sig figs is 2, so that's how many sig figs I know to keep. Oh boy, you don't want to. Jeez. Right. Leading 0, leading 0, leading 0. They're not significant. 1, 2. 2 sig figs, so that's where I cut off. And then I just use the rounding rule to decide, do I round that up or keep it? So that's how we got the point 0012. Right. It can be a difficult concept when you're first introduced to it, but it'll quickly become second nature. There are a few exceptions to the rule. So for instance, when we talk about money, it's always just down to 2 decimal places. No matter what. Percentages, as a general thumb, when you talk about a percent, you keep it to 2 decimal places, which would be, if you're not writing it as a percent, you're writing it as a decimal, 4 decimal places. Right. So there are some exceptions to that rule, but in general, this is the rules. Now we're going to do the opposite. Here we're given an angle in radians, and we'll convert it to degree. Right? Well, again, we're going to use the pi radians is equal to 180 degrees. Except this time, we say that 1 radian is 180 over pi degrees. So we multiply by 180 over pi, or 180 degrees over pi. So you get 180 over 3. This is 60 degrees. Now again, notice, in the previous problems, I didn't write out radians, right? Because again, radians technically are unitless. Degrees are not. You have to write 60 degrees. Five pi over 9, multiply that. 180 degrees over pi. Hundred degrees. Two-fifths. Multiply 180 degrees over pi. or 180 over 5. Maybe 20. No, it wouldn't be. Yeah. And so 20 and then 80 over 5. $16, so 36. And then times 2 would be 72. $72 over pi degrees. All right, 4/3. $180 over 3 is 60 times 4. $240 over pi degrees. Negative pi over 8. $180 over 8. Let's see. 18 over 8 would be 4.5 over 2. And so then multiply it by 10, 45 over 2. And 45 over 2 degrees. Now, this is one of those cases where you actually could write it as a decimal, right? Because 1/2 is exactly 0.5. Two would be, that's an easy one, 360 over pi degrees. 1.53. All right. Again, a couple ways we can do this. We can keep it in terms of pi. 1.53 times 180 would be 275.4, which would round to 275. Right? Or just get rid of the pi. And you get 87.7. Why is this not showing up? There we go. Make it 3 pi over 20. 180 over 20 is 9. And we get negative 27 degrees. And finally, negative 7 pi. All right, 7 times 18. 126 times 10. Negative 1,260 degrees. Yes. Right. That just means it's more than one revolution, right? All right. Now, that was so bad. Oh, now it recognized it after I already deleted it. All right, so given a circle of radius r, let S represent the length of an arc. Then the angle that S passes through in radians is given by theta. I'm still wanting to shape. There we go. Theta equals S over R. How do I want to word it? Let's just say it this way. Right, the area of the corresponding sector I don't know why. No, it's 1/2 theta r squared. Ah, lovely. Fixed. Minute hand of a clock is 12 centimeters long. How far does the tip of the hand move during 20 minutes? Well, that was not the center. Oh, dear. Whatever, I was trying to be fancy. Right, so without loss of generality, let's assume that we're starting the minute hand at 0 minutes, which would be 12. Moving 20 minutes would put us at 4, right? That's the angle that the minute hand's going to go through. And that is the distance that it covers. That is what we're looking for. We need that angle in radians. Well, isn't that... So that's an S, not a 5. And that S is what we're trying to find. Well, doesn't it travel, doesn't it do 1/3 of a revolution? Multiply that by 2 pi. That angle's 2 pi over 3. Theta, all right, because S is theta over R. I'm sorry, theta is S over R, sorry. That means S is theta times R. Right? Theta just says 2 pi over 3. What is R? 12 what? 12 centimeters. So it travels a distance of 8 pi centimeters. Yes? Notice that, well, technically, minute hand doesn't go all the way out to the edge of the clock. It doesn't matter, right? The clock itself would just be a little bit larger. But this is still what we're working with, right? The inner circle. So that's why without loss of generality, I just drew it that way. Are there any questions on angles? Okay. Then when we come back at 7:50, we will look at the trigonometric functions. So I'll see everyone in about 10 minutes. Welcome back. We now move on to the trigonometric functions. Okay. Before that, we are going to look at what we mean by coterminal angles. So given any angle theta, the angle phi equaling to theta plus 2n pi for any integer n is said to be coterminal to theta. Right. So coterminal angles are angles that are essentially just a multiple of revolutions, either counterclockwise or clockwise. Right. So we also use reference angles, call it theta prime. So reference angle is just the acute angle coterminal to the original angle. Each of the next 6 problems, we're going to sketch the given angle in standard position, then state a positive angle and a negative angle that are coterminal to the given angle. All right. Standard position simply means the initial point of the ray is at the origin, and the angle is measured with respect to the positive x-axis. All right, so we look at pi over 6. So that would be pi over 6. I'm going to say in each case, let's say phi is the positive coterminal. I want to move that closer. Well, remember, coterminal. Just add any multiple of 2 pi to it. It'd be coterminal. So if we take pi over 6 and add 2 pi, that'd be what? 13 pi over 6? So there's a coterminal. Not the only coterminal. I'm going to take psi to be the negative coterminal. Well, instead of adding 2 pi, why don't we subtract 2 pi? And that would give us negative 11 pi over 6 as our negative coterminal angle. Again, it's not the only negative coterminal, right? All right, let's look at 5 pi over 4 now. So that would be 5 pi over 4 in standard position. Our positive coterminal. Well, we can just add 2 pi to it, can't we? That would be it's just essentially the same angle, right? It's just, so what I'm doing here is I'm just going 1 additional revolution. Right, so I'm starting at this point, right? And I'm going 1 full circle revolution back to that point. That's a coterminal. In either direction, right? So for the positive, I'm going in the counterclockwise. If I wanted negative, right, I'd go in the counterclockwise. Right, this would be what, 13 pi over 4, right? Oops. And then for the negative, we can just subtract 2 pi, can't we? Should be what? Negative 3 pi over 4? What about 0? Whatever, that's good enough. Standard position. Just be that, wouldn't it? Right, and then positive coterminal, we can just add 2 pi. So we get 2 pi. Negative coterminal. Then we could do negative 16 pi. Just going to stick with the simple one of negative 2 pi, but negative 16 pi is also coterminal. Negative 17 pi over 6 in standard position. Well, the first thing to note, since it's negative, we are going clockwise. It's also more than a revolution. And since we're going more than one revolution, this is how we represent it. So that represents one full revolution, and then an additional bit. Right. In this case, it is going to be easier to find psi first, our negative coterminal. So how did you get negative 5 pi over 6? Right? Add 2 pi, you get negative 5 pi over 6. There's a negative coterminal. How did you get 7 pi over 6? Maybe that's true. But how do you get it algebraically? All right, so what do we have to add to the angle to get the 7 pi over 6? Right, so you'd add 4 pi to it, right? And that would give us 7 pi over 6. So there are two coterminal angles, one positive, one negative. Now let's look at negative 10 pi over 3. Oh dear. That looks better. Again, notice that we're going to be going clockwise. We're going in the negative direction. And it's again more than one revolution. But it is not 2 revolutions. Just as before, in this case, it's going to be simpler to find the negative coterminal first. We can just add 2 pi. That would give us negative 4 pi over 3. Then if we add another 2 pi, that would give us 2 pi over 3. 7 pi over 2. This time we're going counterclockwise. We are again more than 1 full revolution, but we are not at 2 revolutions. Now we're actually at 1 3/4 revolution. Right? 3 pi over 2 is definitely a positive coterminal. Right? Subtract 2 pi. You get your 3 pi over 2. For psi, if we just subtract 2 pi again, we would get negative pi over 2 as the negative coterminal, or a negative coterminal. And 307 pi over 2 is also a positive coterminal. Right. Before we look at this problem, consider a point in the xy plane, P of xy. So there's our line segment, OP. Let R be the distance from the origin to our point. In other words, R is the length of the segment OP. And let theta be the angle that the line segment makes with respect to the positive x-axis. So how many trig functions are there? There are 6 of them. What are they? Sine, cosine, tangent, secant, cosecant, and cotangent. As we will see by the end of the term, you actually only really need 2 of them. Sine of theta is y over r. Cosine of theta is x over r. Secant of theta, r over x. Cosecant is r over y. Tangent is y over x. And cotangent is x over y. What we are going to do is determine the sign of these 6 trigonometric functions in each of the 4 quadrants. This is a very important problem. The results are going to be extremely useful. If we come back up to the plane, remember the 4 quadrants start with the top right and you move counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. R is a distance, right? It is a length. Can length be negative? No. Which means length plays no role in determining the sign of the trig function. The sign of the trig functions are determined solely by the point. Quadrant 1, x and y are both positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. Quadrant 4, x is positive, y is negative. So I'm going to create a table. Each row is going to represent a quadrant. Then each column is the trig function. In quadrant 1, x and y are positive. That means every single trig function will be positive in that quadrant. In quadrant 2, x is negative, y is positive, meaning that the trig functions that involve x are negative. The others are positive. Well, sine and cosecant do not depend on x at all. So those are the only two that are positive. The remaining are negative. right? Quadrant 3, both x and y are negative. So any function that has both x and y will be positive. The others will be negative. Well, there's only two functions that have both x and y, tangent and cotangent. In quadrant 4, y is negative, x is positive. So the functions that do not have y will be positive. Those that have y will be negative. There's only two functions that do not have y, cosine and secant. So those are positive. The other four are negative. Good? You may want to write this table somewhere handy. Like, I don't know, maybe start a separate sheet. Right. The quickest way would be just to memorize it. Second quickest way would be to have a separate reference sheet. What we'll do for the next 3 problems is to determine the values of the 6 trigonometric functions of the angle given the point P, excuse me, given the point P that is on the terminal side of theta. Right? So the point we're given is the point 3, 4. What quadrant are we located in? First. So let's just say that's the point. There's our angle theta. What is the length of this segment? Right? In other words, what is R? Now, it wouldn't be theta times S. And besides, we don't know what S is. It's 5. How'd you get it? No, dear. Yes, technically, you can use Pythagorean theorem, but I'm not there yet, so we're not going to use Pythagoras. Distance between 2 points. Remember the distance formula? Square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. In this case, x1, y1 is 0, 0. Right, so we just get the square root of 3 squared plus 4 squared, which is the square root of 25, which is just 5. Sine of theta is y over r. I'm going to do it this way, I think. Cosine is x over r. Tangent, y over x. Cosecant is r over y. Secant is r over x. Cotangent is x over y. Right, now we have the point -3, 4. What quadrant are we in? Quadrant 2. So let's say our point is right there. Oh dear. Oh, ruler. I need you. That would be our angle, right? What is R? Well, shouldn't be difficult. It's once again 5. And in fact, these values are going to be almost identical. Right? The only I did not want that equals. Right? The only difference is, why did that one bar did not move? Oh my goodness, whatever. is that those functions that involve x are going to switch to negative, right? So cosine and secant will become negative. As will tangent and cotangent. Sine and cosecant stay the same. Now we have the point -1, -3. Oh, of course. That should have fixed it. What quadrant are we in? Right, the third quadrant. I don't know, let's say there. That's our angle theta. What is our R? Right, it was going to be √10. Sine of theta would be -3 over the square root of 10. There is nothing wrong with that answer. Depending on the situation and my mood, I'll rationalize it, but it is not necessary. I will use both forms interchangeably. Cosine of theta. -1 over √10. Tangent of theta is 3, right? -3 over -1. Cosecant, -√10 over 3. Secant, -√10. And cotangent is 1/3. it is okay. It is there. Find values of cosine and tangent given sine is 8 over 17, and we're located in quadrant 1. Say, there's our point. We know that sine is 8 over 17. Well, that means we know that r is 17. And we know that y is 8. X. Well, we're in quadrant 1, so x has to be positive. Since r is square root of x squared plus y squared, we know that x squared plus y squared has to be r squared. From that, you find that x is the square root of r squared minus y squared. And that does give you 15. Cosine of theta is then 15 over 17. Tangent is 8 over 15. All right, let's do one more from here. You're going to find the values of sine and tangent given cosine is 5/6. Well, cosine being 5/6, cosine is positive, right? That means x is positive. Well, if x is positive, then we're in quad 1 or quadrant 4. That should actually be a union because these are sets. So that's going to be important. All right, so we know x is 5. We know r is 6. Y would be the square root of 6 squared minus 5 squared, which is square root of 11. But wait a minute. The absolute value of y is the square root of 11. Right? We don't know if we're in quadrant 1 or quadrant 4. So we don't know if y is positive or negative. If we are in quadrant 1, then y is positive. That would mean that sine of theta is root 11 over 6. And tangent of theta is root 11 over 5. If instead we're in quadrant 4, then y is negative square root of 11. Right? And we have that sine of theta, negative root 11 over 6. And tangent of theta is negative root 11 over 5. If we're dealing with an acute angle, then we can use right triangle trigonometry. Let's say there's our angle in question. Let's call that A. Let's call that O. We'll call that H. Adjacent side to theta, opposite side to theta, hypotenuse. Pythagorean theorem. The sum of the square of the sides is equal to the square of the hypotenuse. Right? Typically, you see it written, right? A squared plus B squared equals C squared. In right triangle trigonometry, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. Secant is hypotenuse over adjacent. Cosecant, hypotenuse over opposite. And cotangent is adjacent over opposite. We're going to find the functions, the trigonometric functions of the acute angles. That's an acute angle, A, right? So sine of A, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over opposite. And cotangent, adjacent over opposite. B is the other acute angle. Sine of B, opposite over hypotenuse. Let's actually make that look like a 5. There we go. Cosine of B is adjacent over hypotenuse. And then tangent, opposite, over adjacent. Secant, hypotenuse over adjacent. Cosecant, hypotenuse over opposite. Cotangent, adjacent over opposite. Remember that the angles, the sum of the angles in a right triangle has to be 180 degrees. Right? Has to be pi. One angle is always fixed to be pi over 2. Right? That's the definition of a right triangle. That means that the sum of the remaining 2 angles has to be pi over 2. Well, take a look. Sine of A and cosine of B are the same, aren't they? Cosine of A and sine of B are the same. Tangent of A and cotangent of B are the same. Secant of A and cosecant of B are the same. These are known as the co-function identities. Typically, you only see 3 of them written out. Right, but these are the 2 important ones. Because there's something else you should have noticed by now. And that is that the remaining 4 trig functions can all be written in terms of sine and cosine. So what I have boxed, you may also want to write down on that separate reference sheet with that table that we did almost an hour ago. I'm going to skip that one. Given that sine of A is 3/7, we're asked to find the value of the trigonometric functions of the angle A. Managed to get to the mute button in time that time. I don't know what's going to happen if I do this. Perfect. Let's call that there angle A. Sine of A, we're told, is 3/7. Right? So we know the height is 3. The opposite side is 3. And we know the hypotenuse is 7. What is that missing length? Right? Root 40, which can be simplified to 2 root 10. God, these allergies are awful. Right? We already know sine of A, right? It was given to us. By the way, that also means we know cosecant of A. Seven thirds. Right? So in a problem like this, you're given 2 of the 6 functions right off the bat. Cosine. Two root 10 over 7, right? Adjacent over hypotenuse, which means we now know secant. Go away. It's 7 over 2 root 10, or, oops, 7 root 10 over 40. No. Over 20. Sorry. Tangent. Three over 2 root 10 or 3 root 10 over 20. And then finally cotangent 2 root 10 over 3. Find the value of the trigonometric functions of the angle B, given that tangent of B is 1.5. Let's call that our angle B. So we know tangent is 1.5. What two sides do we know? Right? How did you get root 13 for R? And what is R? What does it represent? Right, hypotenuse. How do you get root 13? Very good. There are two ways you could do this. You could take tangent to be 1.5, and we know that tangent is opposite over adjacent, so you could write this. Huh. I'd rather not. But if you recognize 1.5 as 3/2, you can write that. And then the hypotenuse is the square root of 9 plus 4. Which is the square root of 13. Sine of B. Right, 3 over root 13, which means cosecant of B, root 13 over 3. Cosine of B, two over root 13. Secant of B would then be root 13 over 2. Tangent was given. which means cotangent is also given. Oh, but by the way, why stop there? Excuse me. If A is an acute angle and we're told that sine of A is 2x over 3, we're going to find an expression for the remaining trig functions. Sine of A is 2x over 3. That makes the opposite, so that length would be 2x, right? Hypotenuse is 3. This missing side, wouldn't it be length squared of 4x squared? No, I'm really messing up. 9 minus 4x squared. So what we're able to do now is write the trig functions as expressions of x. All right, by the way, we already know cosecant. It has to be 3 over 2x. Cosine. Adjacent. Over hypotenuse. Which makes secant that. Finally, tangent. Opposite over adjacent. Right? And that makes cotangent the reciprocal. That feels good. Are there any questions on the 6 trigonometric functions? Okay. So we are flying right along. Wednesday, we will look at properties of the trigonometric functions. All right, so graphs, properties of the trig functions. and then look at the inverse trigonometric functions. And believe it or not, that will already conclude the 4th unit. Right, so the 4th unit is just an introduction to the trig functions. The 5th unit is when we really start delving into properties of identities of trig functions and the analytic trig, which is what a lot of students struggle the most with. So we're already almost done the semester. Sixth quiz is due before our next meeting. Right. Everyone take a look, because I have now graded up through the Unit 2 test. In fact, I'm almost done Unit 3 as well. I just have the Unit 3 test left to grade, and of course that was due this evening. All right, so Unit 3 test may be graded tomorrow. Maybe, but definitely by Wednesday, unless something happens. Everybody have a wonderful rest of your night. See you all again Wednesday evening at 6 p.m.